I am making an online multiplayer stylized FPV drone simulator. Wow, that is so hard to say. What you see here is some actual in-game footage, and if you want to know more about it, then please stick around. Since the last devlog, we have been doing a playtest, and I've gotten valuable insights in where it would be smart to put effort for maximum return. And what seemed to be the biggest problem at the time was that the sim would not run on a potato PC. So that is what we're going to fix next. And here it is, my precious old potato PC featuring NVIDIA graphics. How do you test performance? What I did was to record metrics of the game playing on the low-end system and a high-end system side by side. I could see that the render view family was up to something. But what does that mean? I asked my friend GPT the same thing. It replied with many useful things, but two that caught my attention was profiling and optimizing materials and shaders. Unreal Engine's profiling system is called Unreal Insights, and it's shipped with Engine. When you record for profiling, it's called a trace. Visualizing the trace will give you a highly detailed overview of what's happening in your game. But profiling is a bit too easy, so let's use pen and paper. I started to take notes of the FPS gains I got in the game while removing parts of the map to find the issue. I removed static meshes, I removed the trees, I removed the water, I even removed the sky and clouds, and eventually I only had a plane left with a racing obstacle. From the notes I took, I could extract the results which showed the main contributors to the poor performance were trees and racing obstacles. The trees had way too many leaf cards, and the racetrack obstacles were simulating cloud physics. If we open up the profiler view again, you can see that the profiler mentions skeletal mesh and clothing physics. Profiler is a good thing to have when hunting for issues, but sometimes when you get stuck, then it's good to know it can help to remove parts of a level in order to narrow down the scope. Keep this in mind whenever you add new things to a level. Test and test often. Then you might find issues early, so you don't need to start a full-scale witch hunt in order to find them. I still wanted to save up, so I decided to introduce a smaller map that should be the baseline of the game on a weaker system. I picked a local RC club where I practice as the location, and then went on making that in a stylized version. After applying the fixes, we saw a performance boost ranging from 150 to 200%, and it also plays well on a Steam Deck. In drone racing and racing in general, there are many different track layouts, and on FPV is not different. To avoid a problem where you need to have one level per track layout, I want to develop a system that allows you to change the track layout in-game, and I will call this system the Track Layout Manager. Before jumping head-on into a task like this, I think it's a good thing to get it down on paper first. Drawing things in my coding experience helps me to get a better overview of the system, and that helps with spotting shortcomings, relationships between different parts of a system, and the architecture in general. And it can also help you to avoid something called spaghetti code. And if it's already on paper, it's less things to keep in mind while coding, which means you can use that extra mind space to focus on the smaller details. The general idea is that the player or developer should be able to select the layout. Once a layout is selected, it will spawn that into the world. A layout consists of obstacles. The obstacles contains a static mesh and one or multiple checkpoints depending on the obstacles. The layout should be stored in the file system and preferably a format like JSON, which also means that anyone can manipulate the JSON files to create custom tracks. I would like the manager to have some kind of API with functions to control the manager. This will be used when selecting layouts or creating or editing existing layouts. A cool thing about designing it with editor compatibility in mind is that it's pretty much set up for a future track editor in-game. This would mean that the players can easily create new layouts for the community. Let's say that you want to expose a button to the editor, just like I did in the previous clip, to create the obstacle. You can do that by adding call-in-editor to a public view function. Another useful thing is the with-editor macro. This can be used to stop certain parts of the code to compile outside the editor, especially useful when overriding functions that are only available in editor to fix compilation errors. When I select the layout in the editor, select layout from key is called. This loads the track from a JSON file with matching name. Then we proceed to load layout, which will loop through the stored data that we just loaded and spawn the obstacles and track markers in the loop below. Note that I'm using spawn actor deferred. This will allow you to set up the actor before it's constructed. Seeing it work in the editor that first time is very satisfying. Changing the layout selected in the drop-down menu and then just seeing it fetch another one, it's just so cool. In multiplayer it doesn't work as expected. You can see that there are changes happening on the left side on the client, but the track obstacles is not the same. This is most likely a replication error, and what I mean with that is that the server changes is probably not reaching the client because I made some miss in the way that I set up the architecture or ownership. So I will have to go back to fix that. After some trial and error, I finally reached a state where the replication of the obstacles were fine, but the checkpoints were not. After some more debugging, I could finally find the issues, and here is working replication of the tracks. Here is a diagram of how I implemented the replication. The hosting player is the only one who can change the track. So the hosting player performs a map change. This triggers the manager to spawn a layout. A layout can contain a number of obstacles, and the manager applies settings to a spawning obstacle as this happens. These settings are replicated from the server to the client instances via a setting variable. When the variable is updated, it fires an onRep function which is notified to the clients. The clients then applies the new settings to the checkpoints. These settings includes transform, visibility, and which number the checkpoint is in the race sequence. But how does this work in game? So, integration-wise, the drone interacts with the checkpoint meshes that we have spawned into the world, and it does so via the onComponent and overlap function. I use this function to detect if the drone has passed a checkpoint. If so, then we inform our player controller that a checkpoint has been passed. The player controller then compares the index of the checkpoint we passed with the one we are intended to pass. If these two matches, then we go to the next checkpoint. Hopefully these devlogs are going to come a bit more often after this one, so please subscribe and join the Discord, and with that I'll see you in the next one.